Hello and welcome to Learn Data. It's great to have you on this channel. I'm Nilesh, and in this video, we are going to look at another project which is predicting if a toy would sell on Amazon. And for this is the outline of the video. We'll do a tour of the Amazon.in website and see what data we are going to use and then walk through the code. So this is not a tutorial on scraping the website, but using data from a CSV file and then creating models to do a prediction. So if you have been to the site, you go up here and search for toys. Uh, this is these are the ads that you get, and then here on the left hand side there is toys and games. So within this, let's say if I click on electronic toys, these are the listings that are there. They're sponsored, and then there are some that are the regular listings. So if we go in each of these listings, such as shown here, you have the title right up there. And so this is the title we have. And then we have the seller name. So we have who is selling the toy. And then we have the description, which is the about item and details. Then in addition, we have this other information, assembly required, item weight, etc., etc. So what I've done is I've gone through, collected this information, and filtered out and kept only relevant information in the CSV file. So the CSV file is pipe separated. So if you go up in the column, and so these are the names of columns, and this pipe is what is separating the line. So when you're reading the CSV file, we'll be using a pipe separator there. So now let's go into Jupyter Notebook and see how this has been coded. Here in Jupyter Notebook, I've already written the entire code and I'll put it on GitHub so you can download it from there uh, along with the CSV file, and I'll put the link in the description below. These are the libraries that I've listed for importing. We have NumPy, Pandas, Matplotlib. I did some plotting, which is not included in this code, but if you want to do some plots, you can use this during data exploration work. Then you have these libraries from Scikit-learn, NLTK for performing the text processing, and I also want to import, download the stop words and WordNet that we'll be using. And after that, here we have the data. So the name of the file is df_upload.csv, and here we are specifying pipe separator, and we are also specifying encoding as UTF-8. And the total number of records in this file are 8136. So I had downloaded around 10,000 records, and out of that, after cleaning the data, filtering it, reprocessing it, these are the final number of records that we have to work with. And this is how the data frame looks like after you import. You have the average customer review. So what was the review? What is the average review of particular product given by customers? So if we go back to the listing that we are looking at, so here uh, this particular value 3.6, that's that value, average customer review. Who sold it? Category. So category would be in what toy category that toy is being sold. You have the price. Number of reviews is again how many people ranked. So here you have 8,415 ratings, so that's there. And length, width, and length, width, height, and weight. So if you scroll down all the way down here, here you have the dimensions of the product. So these dimensions, you also have the weight in grams or kilograms. So that's included there. Days elapsed again is when was the post uh, created on Amazon site. That's there. These flags, we are not using them, but they are there if you need to uh, create different types of features. So these three features just indicate that the about item section was present in the ad that was posted for that particular toy. Then we have star num. So that is a feature created to help classify a toy whether it would get sold or it would not get sold. And that's what we are going to do the predictions on. Then you have the title, how many keywords in the title, how many words in the title, how many in about, name, product overview. Uh, you can put this in the model or you can take them off. It's up to you. And then this is the main part, text column. So text has uh, the words from about item, then any descriptions put into just one string, and we are going to use the natural language processing methods to pick each word from that particular text string, create a vocabulary, and then encode the vocabulary for each of the 8,000 rows we have, and then use that as an input to the model to perform the prediction. So star cat num, as shown here, these are the categories that we are going to try to predict, and so that's the data. And down here, the sold by list is what we are going to use for stop words. So that's the additional stop words that we'll put while text processing. And the reason for that is these stop words could bias the model, and therefore if we remove them, then we just have the description of the product. So if you are trying to find if a particular product a new product would sell on Amazon, then all you need is this information: price, what price you would try to sell it, what category you would sell it, what are the dimensions, weights, and how old the post is, and so on. So we have that list, sold by list, and later on that will be deleted. So here what we are doing is we are going to drop. So that column is, I've already dropped that column right here, and here I'm just putting the data frame into X and Y. So df.drop, we are dropping the average customer reviews, star num, star cat num, number of reviews. So all of these are used to create our target Y, which is right here. And for the target, we are using just one column, which is a flag column for star num category. And if we look into this one, if I scroll down here, so that again is encoded category that we are going to use. Now, here it's important to note. So let me go ahead and stop this run. If this has run. Okay, so this part is still running. What I'll do is I'll quit right here because I want to show you a couple of things. So let's stop this run. And it takes a while, couple of hours for this to complete. So I won't be doing that online. If we want to check how many categories are there, we can do that. So here if you try df dot star cat dot unique. So we have two categories, 1 and 2. So 1 indicates that the item will not sell, and 2 indicates that the item should sell. So that's how we have those categories. Then again, we have the stratified shuffle split. And after that, then we move on to clean data. And here you can see that there is an imbalance in the categories. So items that do not sell are more than the items that do sell. And we'll take care of that in few minutes. So when to clean the data, what we are going to do is use this function to clean the data, and then this uses the stop words. So stop words are the most common words in English, and in addition to such as the, a, is, etc. And sold by list are the brand names or the names of the stores that are selling those games. So we want to delete those from the text, that is the description title of the product that we have. And with that, we get a clean text string for each row for the train set, and then we also have that for the test set, and we can stack them to get this xtrain text and xtest text. Finally, we use the TfidF to vectorize the strings, and so here I'm specifying maximum features as 1000. You could vary it based on what results you get and type of classifier you are using. So I found that for this case 1000 was working well, and here you can specify for TfDIF vectorizer the n-gram range, and I've specified 1 2, and we have the max features here. So this processing is done on both train and test set. And so fit on the train set and then use that model to transform the train as well as the test set. So just to point out, we are not fitting on the test set. So the fit is only on the train set. Next, for scaling, we have numeric values, so we definitely want to scale them. So here I'm using the standard scaler to scale the values for both the train and text data sets. And finally, there are categorical values in the column category. So we need to create dummy columns, and this is what pandas allows. So pd.get underscore dummies, and you can create this set of data with numeric values 1 and 0 for each category. And finally, we can combine all of them to get our final xtrain and xtest. And just to avoid warnings from scikit-learn here, the array using the dot ravel to avoid the error. So this will reshape it as is needed by the code. And this is just to see what the xtest looks like right here. And then because we have unbalanced categories 1 and 2, what we want to do is to avoid any bias, we need the number of records for each of the classes to be the same. So for example, if we have 5000 for class 1, then and we have 1000 for class 2, then we can upsample the class 2 from 1000 to 4000 and add additional 4000. So we have a total of 5000 also for class 2. So that's what we are doing here with SMOTE. That is method available from IMB-learn. What this does, it does the upsampling, but it does it in a way where it finds the data points in similar cluster in nearby area within the vicinity of a cluster. So that helps in classification as well, rather than simply duplicating the values from duplicating the records for a particular class. So this method works well in this case. And down below, then we are starting with classification. So the very first one is logistic regression, and I have here I'm running it with both the both cases. The one with SMOTE, so that is upsampled, and one is without SMOTE, which is not upsampled. So we have unbalanced data set. And as you would expect, if the data set if you leave it unbalanced, then chances are that you are introducing bias for the majority class, and therefore your accuracy is higher. That could be the case right here. But with SMOTE, we are still pretty close, 0.85. And now if you try gradient boosting classifier right here, you can see that the accuracy is 0.9. So again, that is pretty good, I'd say, uh, given the data set we have. What we are trying to do is we are trying to predict if a particular toy product would sell on Amazon given its title, about, item description, and other product descriptions such as its dimensions, weight, and days, number of days elapsed since the uh, day it was posted, till the day this particular data was collected. So it could be 3 months, 6 months, a year, etc. And with just this minimal information, we are able to predict with 91% accuracy that the product could sell or not. And here are a bunch of classifiers that I've listed. So you can run all of this. This is just to see which classifiers perform in ballpark range of 80 to 90, and if they do, then you can pick those and then do the grid search CV on them and find the optimal parameters to finalize your model. And here, one point I did not do is creating a validation set. So what I'd suggest you could do is for X test final, or sorry, if you have the X train, so what you want to do is you can split the X train into train and validation set, then do the test on the validation set and never touch the X test until you have the final fine-tuned model. Once you have the fine-tuned model, then what you can do is test it on this untouched test set that we left out. So that will give you more realistic values for accuracy. So here we have these classifiers, and I'm still running. As you can see, there is a star on the left hand side. This is going to take a while, so I may not be able to show you all the results here. But uh, here, a very interesting result we have is that for SVC, we see that with a value of C for C is equal to 1, gamma is equal to 2, we get an accuracy of around 0.98, which is pretty good as compared to the logistic regression, which is at 0.787. This is at 0.86, so they are not in 0.90 range. So this is very good, I'd say. And next step, then what could be done is you can pick SVC in this case, replace that here, and then add the parameters for that particular classification model up here in parameters dictionary, then run this to get the best scores, uh, best parameters, and also you can get the best score, and then use these best parameters to perform the final, to create the final model for classification. And once you have that final model that is created using these best parameters, you can then use your untouched test set to see what accuracy you get. So that's a general walkthrough on this particular uh, code. I did not uh, type it just to save time and spend more time on kind of explaining what I was trying to do. If you have any questions or comments, please let me know in the comment section below. There's one point I want to mention before ending this video is that uh, whenever you're trying to process the data, you want to leave out the test set untouched as far as possible. So for example, in this case, we tried to create a balanced data set, but when we did that, we did not do the balancing for the test set. We did it only for the train set. So that's the general idea. That and again, when we did the fits on the for transforming the data set, we did it only on the train set and not on the test set. And the reason for that is we do not want to build any information from the test set into the train set that could erroneously improve the accuracy of your model. Because if you put such a model in production, then when the model sees a new unseen data set, your accuracy is likely going to fall substantially uh, because of this leak of information from the test set into the train set while creating the model. So that was it for this video. I hope to see you all in the next video. Please like, share, and subscribe. And if you have any suggestions for any other projects, please let me know in the comment section below as well. Thank you.